Feel free to interrupt at any point. And so what I'm going to do with this first lecture is just basically walk you through the syllabus, what the plan is for the course. We've already talked about a lot of that last week, and then we'll get into a high-level overview of traffic safety. Once we get to the latter part of this presentation, I can make the call. I've got a second set of lecture slides that I've also posted, and we can get into those as well, depending upon how quickly this goes. I'm assuming it'll go a lot quicker with 2 students in it with a normal class size, so just an FYI. Okay, so first of all, brief introductions, and then like I said, we'll go over the syllabus and course overview, and then just do some general introduction to traffic safety, basically. So we've already done this at least in last week's seminar, so you can feel free to keep it shorter and sweeter. You'll also be doing the same thing for 849, and I'm asking you to record that via video, but so as not to have you do the exact same thing twice. We'll just go down this checklist for background. And so I can start, obviously. So Pete Savalainen from Negaunee, Michigan. I did my undergrad at Michigan Tech, grad school at Purdue. And I've been at MSU since 2018. Prior to that, I was at Iowa State for 4 years. And prior to that, I was at Wayne State for 8 years. And so I've taught a graduate level course in highway safety at each of those 3 institutions. And we've also introduced some of that content into a few of the undergrad courses, primarily CE 341 and CE 449. And so this is basically a core course for anyone who would be doing any work within the safety domain. And Christmas, New Year's highlights. Again, it was a pandemic, so nothing too exciting there. Just did a bunch of family stuff primarily, and then tried to catch up on some work. So just based on the order you're listed on my screen, I guess, Jordan, you want to go first?
Yeah, sure. All right. So, hey, Jordan Hankin. I'm from San Diego, California. I'm in my second semester of my master's degree. I guess, yeah, I did my undergrad at MSU too. The safety experience, I guess I have a little bit of experience from whatever was in 341 a couple of years back, a little bit in 449, and then touched upon in the advanced highway design that I took from Dr. Gates last semester. Reason for enrolling is needed for the degree requirement, and I also think it will be an interesting course because I feel like a lot of the research that I've been engaged in is safety related. New Year's highlights, pretty tame, like you said, pandemic, so just took it easy.
All right, thanks, Jordan. Travis?
And I'm Travis Holpuck. I'm from Indianapolis, Indiana. Also, second semester of my master's degree, completed undergrad at Michigan State as well. Transportation safety experience is about exactly the same as Jordan's, minus the advanced highway design, which I'm taking this semester. So I'll get some experience from that and this course concurrently. I am interested in this material. That's mostly why I'm enrolled, as well as needing it to graduate. My cat's meowing. And Christmas highlight would be getting to go skiing quite a few times over this break. Thank you.
All right, very good. Okay, so I guess contact information. My office line rings through to my cell. I guess should you need it, I'm also happy to provide my cell. I'm generally pretty prompt at replying to email, although that fluctuates depending on the day and week. And then my office, I've got the shared office in the engineering building, and then also at Spartan Mobility Village, though I anticipate we will not be seeing either of those locations this semester still. And office hours, so I'm basically using the same general set of office hours for both 844 and 849. And so I've tentatively got those set up for Monday, Wednesday from 10 to 11. So that would be right after we conclude the lecture for 849. And then Friday from 11 to noon. And outside of that, we can easily do it by appointment. And so what I'll likely do is just log into Zoom during those periods. And so if people show up, they show up. If not, that's your prerogative. So, but if you need to meet outside of those times, just shoot me an email and we should be able to set that up pretty quickly via Zoom. Communication structure. So this is less of a concern for graduate students and more senior students here, but I do get a flurry of email on a daily basis. So if there's anything related to this course, it's very helpful if you at least indicate in the title. And sorry, I'm referring this as 844, I guess technically, and I forget the course number. This is 890 independent study, but I'll just generally refer to it as 844. And if you could, if you do either, I guess I'll know which it's for, but I've trained my brain to remember what 844 is. So, and again, these instructions are more general that I typically have for all my lectures, because I find students in 341, for example, don't know how to write an email, like they don't address anybody, and it's kind of entertaining, I guess. It makes me feel old and crotchety, but I digress. The course website is where I'll be uploading all the pertinent materials. And so I've got most of the material for week 1 up at this point, and that would include lecture 1, lecture 2, the pre-course survey, and I've got that as a Word or PDF document. It should be quick and easy to either just fill it out in Word or print it out, fill it out and scan it. I don't really have a strong preference there one way or the other. And the other assignments will be developed such it'll be uploading either Word documents or PDFs or something to that effect through D2L. So announcements will be posted periodically here as well. And I will try to make sure we've got reasonably good engagement, both from using the message boards and then also a number of the assignments. I'll have you basically work with the technology, because that's kind of been a good skill that students have been acquiring. So for example, assignment 1, I'll have you put together your solution in PowerPoint slides and then basically prepare a recorded presentation of those slides. That also should help to get quick feedback, as well as demonstrating how well you know the material, and that helps me to come up with questions and so forth. So there'll be some advantages. It's a bit of a pain maybe as compared to normal in-person, but I think there are some advantages to that. So reference materials. So I don't have any required texts or anything to that effect. We have the first edition of the Highway Safety Manual, which was published in 2010, and there's a 2014 supplement. And so we'll be working somewhat closely with those. There is one engineering traffic safety text by Ezra Hauer that's relatively widely utilized in the industry, and there's actually been some recent publications. One of my colleagues at Texas A&M has just published a text as well, so we might pull from that a little bit. And then a lot of this is also going to be coming from various types of NCHRP reports, research syntheses, so forth and so on. And so I'll generally upload these documents where pertinent in the D2L, but it's there's not a nice cohesive text that would be comprehensive and include everything. So it's kind of picking and choosing from various sources, and that would include some resources that are unique to Michigan as well. Some of which you should hopefully be familiar with from some of the prior classes and or research work. So terms of course setup, so we talked about last time, in lieu of any sort of term paper, we'll have you help with developing some content modules, and I'm targeting maybe one of those every other week or something to that effect. So in terms of the grade breakdown, 10% participation, so showing up every Tuesday, participating in these events, posting things to the message board, developing the videos, etc. We'll have a series of approximately 5 assignments, and like I said, those will be posted to D2L and due roughly every 2 to 3 weeks. The midterm exam, my current plan is to have that. It'll be over the course of one day. I don't expect it will take you anywhere near 8 hours, but you'll have the the time at any point in that day to work through that exam, and that will basically bring together all the content we're covering over the first half or so of the course. And then in the latter stages, there'll be a few additional assignments within the other piece there. Like I said, is content development. Grading scale is basically a straight scale as I'd use in any of the grad courses. And then, like I said, PowerPoint slides will be up each day. My plan is to go through these synchronously so we can talk through them in person. There'll likely be a few weeks where we'll have some additional content that I will either record some lectures and post those asynchronously, or you'll just have to be responsible for working through those slides. It's kind of a matter of how well I'm able to handle the pacing of this. And then in addition to that, like I said, there'll be some supplementary reading materials that are posted, and I will try to effectively leverage the message boards and so forth to make sure we get some substantive discussion here as we work through as well. Sorry, my dog is now trying to stand directly in front of the camera. Yes, that's very nice. Lay down. Okay. And then, like I said, 5 assignments, and I've gone back and forth in this, and I think I'm going to go back again. Initially, it said they'd be done individually, and then I was like, well, you guys can do them in pairs, but I'm going to, so let me know here. I'm going to have you do the assignments individually, I think is my plan moving forward. And then for the course content, I'm fine if you guys want to work in pairs on developing some of that stuff. I just think that would be a good model. And the more I think about it, since it's only 2 of you, if you go through the work independently, that's probably would be the best approach for this. And there'll be a few cases where possible, I'm trying to leverage real world transportation data for these, and that will also help to familiarize you with some of those resources. And I'm assuming you probably have some degree of familiarity with those. Have you guys used MichiganTrafficCrashFacts.org at all and the data query tool? Okay. Do you have access, if you worked out with MS2, the resource that's got traffic volume information? Okay. How about any of the road inventory files, like the MDOT sufficiency file, or there's a few publicly available GIS resources? Okay, that's helpful just to kind of give me the context there. Have you seen the highway safety manual spreadsheet tool that we've helped to develop as a part of our prior research projects? Okay. All right, that's just good context for me, if nothing else. And so, like I said, as we work through the semester, you'll get an opportunity to get exposure to a few of these different areas. And like I said, the one midterm exam will give you the full day to work through that. And as a part of that, part of the reason I'm giving you that much time is that one of the advantages in doing this virtually is that I can give you, for example, real world data sets. And so in that case, it's a little bit high risk to try to work through that in just like a 1 hour, 1.5 hour time period there. But to allow you time to work in Excel or whatever other tools might be useful for the purposes of completing that exam, we're going to give you the whole day. And I've tentatively scheduled that for March 12th. So if everyone could, I guess, if both of you could check your calendars and just let me know, make sure we don't have any conflicts there. I believe the week prior, the 5th, is when we have our mini spring break thing. And so I'd have a little bit of review material in advance of the midterm on that Tuesday, if I'm remembering the dates correctly here. And then it looks like the 12th should be a Friday, and so you'd basically have all day that Friday. Any Friday conflicts I should be aware of for either of you guys offhand?
I think we just have a meeting with Dr. Gates at like 1:30, and then the ITE seminar. But other than that, not for me.
Okay.
Same for me.
And then, okay, very good. And then, like I said, it shouldn't take you the whole day. In terms of work-wise, we're probably going to be in that 1.5 hour time frame again. But just for flexibility. And I have lesser concerns with grad courses than I would with undergrad courses in terms of just the exam format. So we can work through that. And then, like I said, the other thing I'm really hopeful you guys can assist on in lieu of any additional term paper project would be a series of short exercises. And so I've actually got one kind of today I wanted to talk through you guys with a little bit time permitting here. But what I'm basically looking at here is just developing some additional modules. So I'll basically be providing all of the slides and other content that we get in a quote unquote normal year in an in-class session. And then since it's an independent study, I mean, we're not going to have as many in-person contact hours. And so what I'm basically looking to do here is to develop some additional short modules, and that could just be simple PowerPoint presentations or like an in-class assignments, short assignments that students can do kind of on the side to reinforce just understanding a key course concepts and things of that nature. And so as an example, today I'm going to show some tools that we can use to compare safety metrics across various countries. And we can do the same thing across various states here in the US with some of the resources we have available. And so I was thinking you guys could potentially look to develop like a tutorial tool or an example of working through that would demonstrate your ability to work with that, and then secondly provide a resource for future offerings. Okay, and we can kind of figure out the best way to sequence that. I'm thinking probably every other week on those, so I'll rotate. One week we'll have the online course content, and the next week we'll have an assignment, and just rotate that over the course of the semester by and large. Okay. Okay, so I guess before we get too far into anything, do you guys have any questions on the general course structure, format, expectations, so forth? Okay. So we'll start with a very high-level introduction to highway and traffic safety. And so the way I typically work through this, I start by us just trying to think through, if you were to define transportation safety, how would you define that? And Jordan, your screen is yellow, which means I think you're unmuted. So if you want to take a first stab, can you define transportation safety or traffic safety for me in your own words?
In my own words, I would say that transportation safety is the goal of ensuring no injuries or fatalities on the network in total.
Very good. Any additional insights there, Travis, on your end?
You say like measured by the number and severity of crashes, like that's how you would quantitatively or qualitatively measure it.
Yeah, so that's kind of right on line in what I've got right here. So when we talk about traffic safety, we're generally talking about how a roadway or a roadway location or a roadway system is defining in terms of various safety metrics. Interestingly, Jordan, you started with injuries and fatalities. The one I would usually go through to first is traffic crashes, but there's several kind of different ways to look at this from a driver standpoint. Obviously, we'd like for crashes not to occur. When they do occur, we'd like to try to minimize the consequences of those, basically reducing the likelihood of fatal or severe injuries. And so from our perspective as engineers, we would play an important role in that. And that would include, design of the roadway, making sure we meet any of the minimum design guidelines or standards, requirements, so forth and so on. Monitoring performance of that system over time, trying to determine where there are deficiencies and how those could potentially be reduced or mitigated. But then even outside of the engineering field, there's a lot of other complementary pieces that kind of come into play here. Because unfortunately, we're relying on driver behavior, and that's generally when we look at crashes. You might have heard this statistic. If we look at all crashes, do you guys know what percentage of those would be due in some part to driver error? There's been several national studies that have looked at this and showed pretty consistent results.
know any specific numbers per se, but probably a
So
large
like
amount.
percentage wise, so 0 to 100%, what percent of crashes do you think would be attributable to driver error?
80, would be my guess.
80?
I don't know. Pretty.
So generally, we're looking 93 to 95% are the numbers we see most frequently. I mean, if you think about it, drivers make mistakes all the time. And generally, when crashes happen, there's other contextual factors that come into play there as well. There's a lot of cases where drivers make mistakes and there's really no consequence or repercussion from that. But, in contrast to what you might see when people, contact law enforcement and report they've been involved in a traffic crash. We'll have a slide that will delve into this a little bit further subsequently here. But anyway, from our perspective, when we talk about safety, we're basically talking about roads that are free from traffic crashes, injuries, and fatalities. Now, if we look at how that's been handled historically as an engineering profession, we have what's referred to as nominal safety and substantive safety. And when I use the term nominal safety, does that mean anything to either of you? If we say a road is nominally safe, any thoughts?
Like it's safe on paper, kind of.
Yeah, and if we were to say a road is safe on paper, I like where you're going with that. I think we're thinking along the same lines here. What do you mean by that?
Like it's following, like the curves, the right radius for the speed, and the guardrails in the right area or whatnot.
Right. So
Right.
basically, when we talk about nominal safety, we're talking more qualitatively. And so, for example, if you look at the AASHTO Green Book, it's important to note that that's a design guidance document. And so they're not, although I use the term standards here, I should note there are guidelines and standards. And so AASHTO basically has recommendations for the minimum curve radius, for the minimum curve length, for stopping sight distance, for various other cases. And so if a roadway is at or above those minimum standards or recommendations, we can basically say, well, it meets some minimum nominal level of safety, right? Likewise, in the MUTCD, in this case, we are talking explicitly about standards in many cases. There are certain scenarios where you need to, for example, sign things appropriately, mark things appropriately. There are recommended best practices based on human factors research and safety research that have led to relative consistency in terms of how these different traffic control devices are applied in the field. And so we can very easily go to a given roadway and assess whether or not the pavement markings and signage and signals and so forth are in compliance with the MUTCD. And on that basis, we can claim some minimum nominal level of safety. And so that's really been an implicit part of the design process for 100 years now, really at this point. But it's really only been over the last, I'd say, 25 to 30 years, particularly, where there's been more of a push for what we refer to as substantive safety. So more of a quantitative, you can use the term data-driven approach to traffic safety. And so that relies heavily on crash data, likewise from that crash information, injury and fatality data. And so we're using this information kind of in combination with some of those design guidance documents that were alluded to in the prior bullet points there. And it really works almost as a cycle in many respects, because those guidance documents in turn are updated based upon findings from safety research, as an example. And so one case, for example, you probably got into the controlling criteria in either highway design or advanced highway design. Are you guys familiar with the AASHTO, the 10 controlling criteria for geometric design? It used to be 13 controlling criteria. So these are basically minimum standards that have to be met. And if you don't meet these minimum standards, you have to seek a design exception. So basically you would need approval from the FHWA if you're constructing or reconstructing a road that doesn't meet those. And so, for example, that would include things like stopping site distance, clearance height, structural loading capacity of the roadway. So just minimum things that have to be met as an example. And so as in one case there, so stopping site distance, they had actually relaxed some of that guidance. And so for sag vertical curves, there really hasn't been any research that's shown that there's a specific safety concern, whether or not that minimum stopping site distance is met. And there's a variety of reasons for that we can get to later in the course, but that was actually removed from the controlling criteria. So that's no longer a minimum requirement that would require a design exception if you can't provide that. And so in contrast, if you're looking at site distance along horizontal curves or on crest vertical curves, there have been quantitative research findings that have shown that safety can be compromised if you don't meet those minimums. And so if you're designing a roadway and you can't provide sufficient stopping site distance at the design speed, you need to seek a design exception for that. And as a remedial measure, you could look at things like, reducing speeds, introducing advisory speeds on horizontal curves as one example there. And so it's really, we're looking at both of these aspects, but design has become much more data driven now than it was particularly 30 years ago, but even 10 years ago. So oftentimes now, instead of just designing a roadway where you're working through the green book and making sure that you're at or above those minimums, it's more of a quantitative process. So there is some granularity here, and there's also some degree of limitation. But we can basically, let's say we've got 60 feet of roadway available. We could compare from a safety standpoint, if we varied the number of lanes and the widths of those lanes and the widths of the shoulders, we could basically determine what the trade-offs are, at least at some level of detail from safety research based on those factors. Okay, so we've talked, you probably had some exposure to what we refer to as crash modification factors and safety performance functions. And so we really have a suite of predictive tools that have been developed by research to help us use an approach that's more data-driven and quantitative in nature. Because if you look at the field of safety historically, and this is still true by and large today as well, is that we tend to make investments and introduce safety improvements at locations that have a documented safety problem or series of safety problems that have a crash history, basically, right? I think one of the best examples I can think of, there was a 4-lane highway between Negaunee and Ishpeming, US 41, where it was previously 4-lane divided. And so if you wanted to turn left coming around this curve up a hill, you basically had to navigate traffic coming in the opposite direction, and you'd have traffic coming behind you. And it was somewhat of an uncomfortable situation. There were safety solutions that could have been introduced there, but the road that you would have been turning left across the divided highway into was relatively low volume. And so while you could look at that and understand that it probably wasn't the safest design, there just wasn't a history of crashes. Now, it turned out one of my friends and a girl I went to high school with was involved in a fatal crash at that location back in the early 2000s. And then shortly thereafter, they had introduced some improvements. There's a center left turn lane there, for example, now. But from our perspective as engineers, ideally, we'd like to be more proactive there. And so that's what has largely led to a lot of this, because this becomes a particularly acute issue in rural areas, as an example. And so if you're on rural highways, there's just so little traffic. Generally speaking, it takes quite a while for safety patterns to emerge, crash patterns to emerge there. And if we try to focus on fatal and severe injuries, those tend to be even more rare on a site-by-site basis. And so by introducing some statistical methods and some of the more quantitative focus here, we're able to make decisions that are a bit more proactive. So hopefully we would be able to see better performance system-wide in how we determine where those safety improvement programs and projects are most needed. Okay. All right. One other quick point, and I just received an email last week on this, and I'll have to circle back. I forget if that was coming from the FHWA or elsewhere, but this has been a big discussion nationally for over 20 years now. If you go way back to when I was going to school, we'd still hear quite a bit the term accident, and somewhat sadly, I'm on the editorial advisory boards for Accident Analysis and Prevention and Analytic Methods in Accident Research, which are considered the two top journals in traffic safety, but they don't use the term crash in their title. They use the term accident. And so you probably know where I'm going to be going with this, but back in 1997, NHTSA formally started using the term crash as opposed to accident. Why would they do that? Jordan, any thoughts?
Sorry.
Go ahead.
Because an accident implies the driver error, maybe?
An accident implies the driver error, or it kind of implies that the driver didn't make an error, right? It's just, oh, it was bad luck, bad circumstance, basically, right? And that nomenclature is still widely used today. And so the primary factor here is, to my prior point, 93 to 95% of the time, it's the driver doing something wrong or not adapting appropriately to the roadway conditions. And so there are definite and definitive causal factors here versus just some bad luck and unfortunate sequence of events. Now, there's some cases where something could fall off of the bed of a truck, or a deer could run out into the road. And in a lot of those cases, I guess you could largely, make the argument that it's an accident. But then if we drill down deeper, if the driver was paying more attention, even in those cases, maybe they could have stopped to avoid the deer. Maybe there are other things that could have been done there. And so part of the reason for this, there's the liability standpoint here, and just public perception as well. So if we think about traffic safety, and we'll get to this in one of my subsequent slides, there are some significant, it's a significant public health problem. And if you look at the public, I think they're largely unaware of the magnitude of how big this problem is. And as a part of that, that's another of the motivations for, using the term crash as opposed to accident there. And so a related note, if we just think about this from a big picture standpoint, like I said, crashes are a very severe concern nationally and internationally. But there's so many more events that occur on a daily basis where a crash almost occurs. And so from our perspective as engineers or safety analysts, we're really interested in more broadly understanding those various circumstances that contribute to the likelihood of a crash occurring, whether that's specific geometric or roadway factors, certain driver groups. There's a variety of different ways we can try to investigate the nature of these safety problems here. But generally speaking, we're restricted to focusing just on this very narrow subset of events that actually lead to a crash occurring. We are making significant improvements in trying to identify near crash locations, and there's various ways we can do that. We're working on a project with Ford right now, where we basically get reports out anytime they have an harsh acceleration event, a harsh deceleration event, or a harsh cornering event. And so we can basically look at where those events are occurring from a geospatial standpoint. And we could have 5 to 10 to 20 times as large of a sample then, and we can make a little bit better decision because we're capturing events that could have resulted in crashes. Okay, so just a few important factors that help to quantify why it can be very challenging for us as engineers to try to address these traffic safety issues that have been problems since we started driving, basically. Okay. Now, just to try to get a little sense of the scale of this problem, I've got some statistics here that with the most recent data that's available, I think that's 2019 here in all cases, although I couldn't verify from the World Health Organization here. So if we look globally, Travis, any idea how many people are killed in traffic crashes each year around the world?
Probably a few million, would be my guess.
Yeah, so 1.35 million is the global number, which is a staggering number. If we look at beyond that, at the number of persons injured, that's somewhere in the neighborhood to 20 to 50 million. Now, naturally, you see that's a huge range, so we don't have a lot of confidence in that. And one of the reasons for that is there is a lot of inconsistencies in terms of how these data are reported and what information is collected. So I taught a short course in India back in the fall of 2019. And over there, they do a reasonably good job of tracking data for all their fatal crashes, but they don't have nearly the degree of sophistication in terms of the reporting mechanisms we have here in the US. And so as you look at some of those larger developing countries, that's an issue. There are a few other countries that historically have not reported that data, and I won't delve into the politics there, but we'll look at a map in a few minutes about some of those countries that aren't reporting that information. Here in the US, any idea how many crashes would be reported to law enforcement on an annual basis? So we got what, 250 million people roughly. How many crashes would those persons be involved in, would you suspect?
5 million.
Yeah, I was gonna say like 10, but
yeah, so around 6.7 million that are reported to law enforcement. Now, they're generally these standards and vary from state to state. But in Michigan, as an example, crashes should be reported if an injury occurs as a consequence or if there's at least $1,500 in property damage. There are cases where crashes are reported at dollar values below those thresholds or where persons aren't injured. But there's also a significant number of crashes that meet or exceed those thresholds that aren't reported for various reasons as well, including concerns about impacts on insurance rates, if someone's been drinking or driving or engaging in other illegal behaviors. But so we know there's significant underreporting. Does anybody know if we looked at the total number of crashes, not just police reported, what that number would look like?
that's what I was saying. Maybe it's around like 10 million at that point.
Yeah, so if we look nationally, roughly 50% of crashes are underreported. So we're looking more in that 12 to 14 million range, somewhere in that area. And again, there's generally speaking, if we look at how severe those crashes are, the underreporting rates are very low for property damage only crashes, and they're much lower underreporting for the more severe crashes, obviously. So now, from our perspective as engineers, that's somewhat challenging because we could, for example, have twice as much data to work with, right? But in lieu of having access to that, it makes our job somewhat more difficult. And it also helps to reinforce the severe, societal implications that we see here. So 6.7 million crashes, and those result in 2.74 million injuries roughly. So as those numbers suggest, the vast majority of those crashes, even those that are reported, are still going to be property damage only. But there are a significant number of injuries and also traffic fatalities. Do you guys have an estimate of how many of those crashes would, or how many fatals would occur each year in the US as a consequence?
20,000, 25,000.
Okay, 25,000. You want to throw a guess out, Jordan?
I was gonna say around the same, actually.
Okay, so if we look at the most recent data, we've got around 36,000, and that's been a gradual decline. If we go back, the peak in traffic fatalities, we were around 60,000 per year. If we go back into the 1950s, 1960s, and keep in mind traffic volumes weren't nearly as high at those points, but vehicles weren't as safe, roadways weren't designed as safely as they are currently. And so there've been a wide range of different factors that have helped to contribute to that decline, but still, we're having a staggering number of people die every day. It's as if you have a large plane crash occur on a daily basis, but you rarely see much coverage of this in the news, I would argue, interestingly. And so helping to reinforce just the magnitude of that problem. Now, as we focus here in Michigan, maybe you have a little better handle on this number. Anybody know how many crashes are reported in Michigan each year?
like 200,000.
So 50% more than that. So over 300,000. Now, among those, there's a very large proportion of those that are deer vehicle involved crashes. And so your number's probably pretty close if we were to focus just on purely vehicle involved crashes, I would suspect. Those crashes result in a total of around 75,000 injuries on an annual basis. And then fatal statistics. Do you guys recall roughly where we're hovering in terms of fatals the last few years?
I think like right around 1,000.
Yeah, so we've basically been right below 1,000, and so 985 based on the 2019 data. It looks like those numbers have gone up, interestingly, in 2020, despite the fact that traffic was down significantly. But this just helps to kind of reinforce the magnitude of this problem that we're all trying to deal with as engineers. Okay. If we look globally, so back to my prior point, this is coming from the World Health Organization. And so basically, this is just a color-coded map detailing the number of traffic fatalities that occur in each of these countries. There are a few countries shown in white here where data are not available for one reason or another. But generally speaking, red is bad, green is less bad, I guess. And so in looking at this, does anybody know what this red country is?
India.
What is it?
India.
Yeah, so that's India. And then interestingly, we have one of the African countries here. I have to double check here if this is
That's Nigeria.
Nigeria.
That's what I
Yeah.
was gonna say.
Yeah, so I believe that's Nigeria. And so that's kind of interesting here. We've got big differences here. And if we think about the reasons for this, now the US is in the orange, and so certainly on the worst end of the spectrum here. And if you look at some of the other countries, a lot of this is being driven by what countries are tending to show up darker here or more red as compared to the others? Any general
Higher
feedback?
population.
Yeah, so the big thing that's happening here is this is where the most traffic is occurring. And so as a consequence of that, it doesn't necessarily mean that those countries are the least safe, but certainly they're experiencing the greatest losses on an annual basis. So we can also normalize this if we look at the rate per capita. The US doesn't look nearly as bad anymore. Interestingly, even India looks a lot different, a lot better from this perspective, although there are a few caveats there as well, just due to differences in the nature of travel. But some of the other countries now start to come up higher on that list. In an ideal world, and we could have quite a bit of discussion of this, and we'll start getting into this, I think, as soon as next week. There would probably better ways to normalize than just population. For example, vehicle miles traveled would be another way of looking at this. But there are some advantages and disadvantages in terms of how we normalize that. And that's one thing I want to talk about as we work through the class. And as we think about some of that additional content that we could develop, I would like to see us collectively as a group figure out how to better utilize this World Health Organization data, and so play around with this a little bit. And so I'll post some details of what I'm thinking in terms of that first interactive assignment, but I think I'd like to have just an exercise where we play around with the information that's available here and try to better understand why we're seeing some of these trends that we're seeing, and what other important information may be important and may play a role here. So, make sense? Okay. Now, if we look here in the U.S., so like I said, we're up in that 50 to 60,000 range as we go through the late 60s, early 70s. And since that time period, we've seen dramatic declines. Now we've actually started coming back up a little bit. So apologies, as this chart is now more than 10 years old here, but there were dramatic declines in fatalities over a period of 30 to 40 years. And there are several reasons for that. Can you guys think of any potential changes that may have occurred? Now, a lot of this, I guess, would predate your birth even in many of these instances, but any ideas some of the changes that would have coincided with this, or why we might see peaks during certain periods?
Seatbelt use, and then like the dip in the 70s from less driving for the oil crisis?
Yeah, great. So we've a lot of this, and this kind of gets back to my prior point on the World Health figures. This is at least partly a function of how much people are traveling. And so just traffic growth was enormous as, people got back. And after the Second World War, everyone started getting vehicles. Our cities started becoming more dispersed. There was just a lot more travel overall. And so we saw these dramatic increases. And then we've got those periodic fluctuations, some of which relate to issues. Sorry. Oh, you chewed up a Peppa Pig toy. That's a bad girl. That's a bad girl. How'd you get that? No. Sorry, guys. So we had the, I guess I won't edit this. I'll probably just post as is, but this should be entertaining. So the oil embargo in the mid-70s would be an example. We had some mini and larger recessions in the 80s and 90s, but there have been a variety of different safety factors. So seatbelt use has been a huge one. And that became a national mandate in the early 80s. And if you track seatbelt use versus traffic fatalities, you see that belt use basically is going. Now, is this going the right way? Am I going left to right or right to left in this increasing trend on your screens? So is this
right to left for us?
So I want to go like this if I'm like plotting a line. Okay. I flip my screen and it confuses me now every time I see it here. But so what you would expect to see as that belt use is going up, fatalities are then going down as a consequence of that. Okay. Outside of that, there have been a wide range of other improvements. So just things like anti-lock brakes were finally mandated by NHTSA in the late 1990s as one example. There are all sorts of safety features that have been introduced over time, including front airbags, side curtain airbags, etc. Vehicles have been designed so that they've got greater deceleration capabilities. We've got a lot of advanced driving assistance systems now. So, we're moving towards the point where the vehicle can help to intervene. There have been much stricter penalties for drunk driving over this time period as well. With that being said, the U.S. lags significantly behind various other countries. So Canada, for example, you can't even drive into Canada if you've got a DUI on your license. And if you get a DUI while you're in there, they will take that away immediately. And so we haven't seen quite the same level of effort legislatively here in the U.S. to address that issue as compared to some other countries, including Canada and much of Europe. But there is a lot greater social pressure even now versus, say, 20 years ago that has played a role there. Some of these other changes. So coinciding with the oil embargo, we saw the national maximum speed limit was introduced in the 1970s. And that was basically started to go away in 1987 and then was fully repealed in 1995. And since that point, a lot of speed limits have started to go up. And so despite the fact vehicles are being designed to be safer than ever before, speed limits are higher. We've had some other issues that have emerged as well, distracted driving, things of that nature. Some other changes, so driver training. When I went through driver training in the mid-1990s, we didn't have any of the graduated driver's licensing programs that I'm assuming both of you would have went through in your respective states. Crash response has been a big one. So we've got things like OnStar, cell phones. So I was involved in a rollover crash in the summer of 1998, I think. And I didn't have a cell phone at the time, but somebody who drove by and saw the the crash, pardon me, happened to, in this case, it was a deer, so one could argue, but I digress. But we did see that that's something that's helped to improve response times. And so if we look at safety from a more macroscopic level, we'll tend to see fatals are much more prevalent in rural areas. And part of the reason there is higher speeds, but part of it is also it takes longer to identify and respond to those crashes. And then one of the other big items in the early 1980s, states we're basically required to develop highway safety improvement programs, and we'll start talking about this next week. But HSIPs are basically high-level plans geared towards aggressively reducing traffic crashes, injuries, and fatalities. And so we'll talk through the ways that road agencies aim to do that. So there's a lot of optimism in looking at this, but we've basically seen a straight plateau over the last 10 years. And as you saw in the preceding slides, we're up closer to 40,000 fatalities again now at this point. And so there are also a few areas where we've seen larger numbers, pedestrians and bicyclists, motorcyclists, so some of these more vulnerable users, particularly over the last 10 to 15 years, have seen some dramatic increases. Okay, so our first assignment for the semester, this is going to be due a week from Friday, basically. I'm just going to ask both of you to identify 2 locations, preferably somewhere near MSU or the greater Lansing area, where you believe there are some transportation safety problems that could be addressed in some form or fashion. And so as a part of that, I want you to basically document the location using either aerial photographs or street level imagery here to demonstrate why there's a problem here. You can feel free to obtain crash data if you have that capability at this point. No, we haven't started getting into that aspect of the course, so it's not a requirement here. This is more just from your perspective as a driver. Are there some locations that you feel would be somewhat unsafe? And like I said, 2 locations, I'd like for one of those to be an intersection and one of those to be a road segment, and keeping that rather general. And so each of those, I'm looking for a minimum of 6 slides, and you can obviously go a bit more than that, but basically telling a story about which locations you selected, why you think there's elevated risk there, and then any potential solutions that could be used to address those. And so I've noted here, you can include drawings as a part of that. I mean, it doesn't need to be a fully detailed CAD drawing, for example. I'm not looking for that necessarily, but just some schematics about potential improvements that could be introduced. And so we'll have you basically record that PowerPoint presentation, submit through D2L, and that is basically what assignment 1 is going to be. Any questions on that one, guys?
Yeah, do you want like video recording or just like a narrated audio PowerPoint?
I don't have a strong preference. You can either just narrate a PowerPoint, or depending upon your level of sophistication with the technology, you could embed a video, or however you'd like to do that. But I guess the only requirement on my side is that it's a video, so an MP4 or something similar, and I'm fine with slide narration or you talking with or as a alternative to that. So
okay, so you wouldn't want us to just upload like a PPTX file. You want us to actually record it?
Oh yeah, I see what you're saying. Yeah, ideally, what I've found is that sometimes, well, I'm sure you're both experts in PowerPoint at this point, but I'd use that for some of my prior courses, and sometimes it gets a little goofed up, and I haven't been able to troubleshoot what the reasons for that are necessarily, but I guess on that note, do you guys have the capability to record on your end? Do you have a program that you could use to do that?
I'm sure I could figure it out, yeah.
Okay. I've been using Camtasia. I mean, you could also just use Zoom, frankly speaking, and just record your Zoom, so it shouldn't hopefully be too big of a lift on your end there. But yeah, so as opposed to just embedding audio in the PowerPoint slides, I guess my preference would be to have that as just a standalone video file. Okay. Other questions? Okay.
Yeah, I had 2 questions just about the course, actually. So you're mentioning the message board. When will we have to be using that? Will we know about that?
Yeah, I'll give you guys a heads up. The better demonstration will be in 849. Since we've got more students in that, I'll be using that a bit more frequently. But I guess I'll let you know if you need to check in on something. It should, I believe there's a way for me to help set alerts for that type of stuff. But that should show up right when you log in. So
okay. And then, sorry, last question. Do you want us to have the PowerPoints, like the slides, like do you want us to review those before these meetings or do that like this week for these two, if you see what I'm saying?
I mean, if you can go through them in advance, that's fine. My expectation in going through them is that you won't necessarily have reviewed the slides. But obviously, I didn't have time to get into any of the legislation stuff here today. So you'll kind of be on your own to walk through and review some of that. I'll also be posting a couple PDF documents that will provide a little bit more detail on some of those pieces there as well. But so yeah, short answer is I would encourage you to review them in advance, but I will operate as though you have not necessarily done that every time. So okay,
Thanks.
yep. And then, like I said, there's a pre-course survey out, and so I'd like you to please complete and upload that by this Friday. And then I believe I've also got the second lecture, which is focused on safety-related legislation. And so as an example, I'll probably post on the message board just a few thoughts I want you guys to think through, a few questions to think through as you review some of that information, just as to the nature of those laws and some of the pertinent factors that I would discuss if we were to be meeting and going through all those in person. Okay. Okay, any last questions? Okay, so I guess just keep me posted if anything comes up. I'm sure I'll see you guys at the seminar on Friday. And then, like I said, we'll just look to D2L for most of the updates there, okay?
Sounds good.
All right, thanks guys. Have a good one.